Good morning, Algebra 2 Extended. We're up to section 3.5, day 1. This lesson's going to be broken into 2 days. We could do it in 1 day, but it's long. So I'm going to kind of cut it in half, and at the end you'll see what we expect you to do for homework tonight, which is not a whole lot, but we'll go from there. Next, as you read this, wrapping up, not really wrapping up, we're only on, Wednesday today. So wrap up your 3-4 day 1 and 2, watch this video, complete your, today you're going to complete 1 through 4. Whoa, you're going to complete 1 through 4. Number 6 and 7 on here is all we really expect you to do after today. Don't do them all because you're going to miss some shortcuts, okay? Make sure you submit homework by Monday night, and Friday we're going to have a formative where there's a PDF online. I got this slide in the wrong spot. I'll have to move it later. No big deal. Essential ideas, basically, what we are doing, we're determining the number and types of zeros for a quadratic function. We've done that using the discriminant. Today we're going to do more solving equations, and some of those equations may or may not have complex solutions or the imaginary number I in them. We're going to use the fundamental theorem of algebra. We're going to choose the key for this section is right here. Choose the appropriate method to determine the number of quadratic zeros or zeros a quadratic function has, okay, which means choose the appropriate method in order to solve a function. And what I'm going to do, there's hopefully going to be lots of pausing in here. When I say pause, please pause and attempt the problem. So I'm going to say, please pause and do these quick 7 warm-up problems and see if you did them right. And I'm going to go do them, and I'm just going to show you what they are when they're done. So what I did was I highlighted up there, whenever you're factoring, please, please, please remember, always look for a greatest common factor first. It makes life easier. In A, there is no common factor, so then I just made the 2 parentheses and factored. However, in B, when you look at B, there is a greatest common factor between 3x squared and negative 27, so I took it out with 3. Please do not stop here. That is a difference of squares, so that continues to factor, and we want things completely factored, so that's where we're getting our answer. Letter C, there's a greatest common factor in there. These two each have both a 4 and an x in common, so when I take a 4 and an x out of each, boom, there I am. D, a lot of people get all monkeyed up, but they factor it right, and typically they leave their answer here. But remember, in math, we like to do things called simplifying, meaning write it in its most simplest form. So x plus 4 times x plus 4 technically is x plus 4 quantity squared, because there's 2 of them, that's why it's squared, and they're multiplied together. Okay, find the value of the discriminant and state the number of zeros, okay, aka zeros, asking you to solve things or whatever. They're going to be asked in different ways. Zeros, also known as intercepts, the roots of the function, the solution of the equation, they all kind of mean the same thing. Remember, the discriminant is simply b squared minus 4ac. Well, if I find it in letter E, my discriminant value is negative 47. Whenever it's negative, you have 0 real solutions, meaning your parabola, if graph, does not touch the x-axis. In letter F, we get a discriminant value of 9. It's positive. Because it's positive, our parabola will hit the x-axis at 2 places. When I do letter G, I get a discriminant of 0. Wow, what that means is there's one real solution, which actually means the vertex is on the x-axis when you look at it in a graph. Okay, moving right along, exploration and groups. Well, we're not going to do a lot of group exploration because you're at home, but I have highlighted there. The fundamental theorem of algebra is highlighted. It's a fundamental theorem. It's a very important theorem. Okay. It states that any polynomial equation of degree n must have exactly n complex roots or solutions. Every polynomial function of degree n must have exactly n complex roots. All that means is when you are looking at an equation, when you find the largest power of x in that equation, if it's an x to the third, it will have 3 solutions. If it's an x to the 7th, it will have 7 solutions to it. okay? And that's combining real solutions and imaginary solutions. And when you combine the two, that's why they call them complex roots, okay? Based on the fundamental theorem of algebra, a quadratic equation should have two, not should have two, it will have two complex roots. Notice D and G above, the discriminant was equal to 0, which means they only have one quote-unquote 0 because the vertex is located on the axis. However, if we think about a definition here that we're going to get, when the discriminant is equal to 0, the root of the quadratic equation is called a double root. The reason for that is check it out, when I factor that thing, I actually have 1, 2 factors. Because they're the exact same factors, that's why it's a double root, okay? And what we're going to cruise along is we've graphed quadratics in 3 different ways. Factored form, which is f of x equals a times x minus root number 1 times x minus root number 2. We've done standard form. Oh, wasn't that the fun one? F of x equals ax squared plus bx plus c. It actually wasn't that bad because all we had to do was find the vertex and do the 1, 4, 9. Vertex form was the easiest, where we had f of x equals a times x minus h quantity squared plus k, and they called it vertex form because our vertex was located at opposite of h, same as k. And then we could plot that vertex, 1, 4, 9 it, done deal. Okay? In this lesson, we're going to learn how to algebraically find. Algebraically means using algebra, not our calculators. Our calculators are only used to crunch numbers. If we're algebraically finding them, we're not graphing them in Desmos and finding the solutions and writing them down, okay? And we're going to find the complex zeros, okay? Some are real, some are imaginary, of any form of a quadratic function. Sounds like fun. It doesn't sound like fun. That is fun, so let's get after it here, okay? Now, one question I've been getting from a lot of students coming back as I keep sending homework back, you're not showing your work, you're not showing your work. And I keep hearing, I don't know how to show my work, it doesn't make sense. Let me tell you, every video you're watching models the kind of work you're supposed to show. So, when we're in factored form, okay, remember, we're already factored. We just take each factor that has an x in it, set it equal to 0, that's a 4, equals to 0, and we solve them because in factored form, what we are doing, we are using the zero product property to find out x is negative 5, x is 4. I'm going to hit pause. You do the next 5, and I'm going to come back and see if you got them right. Back at the factored form, why don't you check these all out, see how you did. Bottom line, a lot of people always say, if I fast forward to some of them, like in number 1, Mr. Kruger, how come you didn't set negative 2 equal to 0? Well, we only set factors equal to 0 that have x's or variables in them, and negative 2 is kind of it's just a number. It's naked from a variable. It doesn't have one, so therefore we don't care about it in this case. Now, if you look at number 4, if I asked any student, I got 1/4 x equal to 0, how do you solve that? They're going to say divide by a 4th. No, don't divide by a 4th. Kill fractions. You want to multiply both sides by 4 to kill that, to get x equals 0 times 4 or 0, okay? Multiply by the denominator of the fraction to get rid of it. Now, as you tune into number 5, check it out. I have 2 of the exact same solutions. You know what that is? That's a double root. Anytime that happens, anytime something squared like that, well, I'm not going to go there. I'm not going to go to this one. But anytime I solve and I have 2 of the same solutions here and here, that's a double root. We're going to call it a bouncer later on. And then typically I'm going to bebop back up here to number 3. Most people are going to look at number 3. They're going to tell me the solutions are negative 3 and 1. But they're not using the zero product property. You set the entire factor equal to 0, and then you solve for x, and you get negative 3 over 2. All right? So, moving right along. Standard form. Well, standard form is the fun one, because let's face it, that's typically how our functions are given to us, in standard form. Well, there's actually 4 ways to do this. Factoring. Kruger thinks factoring is always the fastest. Always, okay? From there, we have a square root method. There's a particular instance in which allows us to know that. We have the quadratic formula. Everybody remembers that. Opposite of b plus or minus the square root of b squared minus 4ac all over 2. It's a really pain in the butt. And we have completing the square. And you're like, whoa, we just learned that. That's really hard. Well, actually, it's not. Easiest way is factoring. Square root method is second easiest. Completing the square totally kicks the butt of quadratic formula. Most of my students love the quadratic formula. Well, you guys already know how to factor. This is nothing new. I want you to factor these 4 functions and then solve them by using the zero product property, which means factor it, set each factor equal to 0, find out what makes each factor equal to 0, and I'll be back with the answers because this has been taught to you a few times this year already. Let's make it happen. I'm back. Hopefully you got these 4 done. If your work is all filled up like you got right here, you are showing phenomenal work. If you're missing a lot of this work that I got in here because you're quote unquote doing it in your head, it's really not okay, guys. Basically, here we go. Factoring. Finding the zeros of by factoring of a quadratic function. Well, before we can solve an equation, we have to have it set equal to 0. That's why that's the first step I did. Then what I do is I factor x squared plus 7x minus 30. Well, that factors to x minus 3 times x plus 10. I take each factor using the zero product property, just like we did earlier, and I set those factors equal to 0, solve for 0, and in number 7, I get x equals 3 and x equals negative 10. They are both solutions to that equation. When I look at number 8, oh, check it out. Number 8 is missing my constant. It's missing my constant or just my naked number. Anytime that happens, you can solve by factoring super fast. It really hurts my heart when I watch students pushing things like this through the quadratic formula after they learn it. Well, there's a greatest common factor between 14x squared and 21. It's 7x. So if I factor a 7x out of each one of those, I get 7x times 2x minus 3. Well, 7x equals 0 when x is 0, okay? And 2x minus 3 equals 0 when x equals 3 over 2. Check it out. This solution here is not x equals 3 because there's a little coefficient on that little rascal, and watch where he goes every time. That's going to happen. Number 9, when I factor it, I get x plus 5 times x plus 5. And I get 2 solutions, x equals negative 5, x equals negative 5. You know what that is? That's a double root. You know what a double root happens graphically? That's where the parabola kisses the x-axis at the vertex. That's all it is. Now, number 10. Lots of people are going to say, oh, I wouldn't do it that way. That's fine. You don't have to. But I would always factor these because I get x squared minus 9 is a difference of squares. It factors x plus 3 times x minus 3. That way I know I get 2 solutions. Okay, it's quadratic. I'm going to get 2 solutions. Count it. 1, 2. One's negative 3, one's positive 3. Typically, I would ask a student, well, they get there, oh, what's the square root of 9? 3. Nah, no. The principal root of the square root of 9 is 3. But when we're solving an equation, there's 2 solutions to quadratics, okay? So that takes us to the next one. The square root method. Well, let me squirrel this little bugger up here. And the square root method is what we see in here. I'm going to highlight it for you. Anytime the b term is missing from the quadratic equation, there's no b term, all I see 1x in there. When I see it, I'm like, whoop, there it is. I only see 1. Whoop, I only see 1 in the whole equation. Whoop, there's only 1 in the whole equation. When that happens, we solve by the square root method. Okay, x squared minus 10 does not factor to the likes of which your brain would comprehend at this time. So we say 0 equals x squared minus 10. We're going to add our 10 over, okay, plus 10, I get 10 equals x squared. How do I undo an x squared? Well, what do? I square root that little guy. But now remember, please do not forget the square root of x squared is x equals the square root of 10. I don't know, it's not a perfect square, so I'm going to call it the square root of 10. But whenever I'm solving an equation, I have a positive and a negative root because there needs to be two, count them, 1, 2 solutions, okay? So I'm going to hit pause and I'm going to let you solve out these next two examples quick. Well, in example 2 and 3, 2 and 11, whoa, that's kind of marked up a little goofy. Well, it's two examples and then you get to try number 11, so that's kind of wonky. You didn't notice that till now, but you set the thing equal to 0. So right here, 0 equals 3x squared plus 15. What do we do from there? Well, we subtract 15 across and we get negative 15 equals 3x squared. And divide by 3, that's why that negative 5 equals x squared. And then to get rid of the x squared, we take the square root and we get x equals plus or minus the square root of negative 5. If you have that written, you are not correct because we always have to simplify our roots. And what we need to do is we need to remember this is square root of negative 1, square root of 5. So x equals plus or minus, that guy is my I, square root of 5. Okay? And what I need to do is hit pause a second. Okay, also number 11 there. So when you solve that out, if you had x equals plus or minus the square root of negative 5, you probably got x equals plus or minus the square root of negative 7. But if I can stop for a second, notice all I'm doing when there is one x in the equation, and when I'm saying 1x, when I set it equal to 0, I see one visible x in there. What you do is you get that x all by itself. So I get it down to here, subtract 14, divide by 2, and I get x squared equals negative 7. I just need to remember what are my inverse operations. How do I undo x squared? I square root it. And anytime I'm solving an equation and I square root something, I have to get a plus or minus on the number side of it. X equals that, but I always have to simplify my radicals. So x actually equals plus or minus I square root of 7. When I simplify that, this guy is actually square root of negative 1 times square root of 7. That's I. There's no perfect squares in there, so that's why that's what it came to. We're coming up to our last page that we're going to do today. My nemesis. I can't stand the quadratic formula. There's a ridiculous amount of work, but it does have its place with that being said. Okay? Quadratic formula, what happens if I have a function that is not factorable? Okay? And it contains the linear term, and it. So I can't factor it, and it has the b term. Because if I'm missing a b term in an equation and I'm using the quadratic formula on it, yeah, we don't want to do that. That's a big fat waste of time. So just like we have this thing, we got x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So when I look at this, I can try to factor 3x squared plus 7x plus 3 all day long. And a lot of people always come to me and say, yeah, well, I don't really know it that well, so I can't factor that good, so I just always use the quadratic formula. If you're going to continue in math beyond Algebra 2 Extended, you need to learn how to factor. If you don't, you're going to be wasting an obnoxious amount of time, okay? Just going to say that. So here, when I set it equal to 0, I know A is 3, B is negative, it's not negative, it's 7, and C is 3. So I'm going to come down. X equals opposite of b plus or minus the square root of b squared. Now check it out. You see how I put that b in parentheses when I square it? I do that so I know that whatever that number is going to be positive. Minus 4 times 3, or a, times c, or 3. Then I'm extending my root all over 2 times a. So I'm going to come along. Well, negative 7 plus or minus the square root of 7 squared is 49. Negative 4 times 3 is negative 36. So minus 36 over 6. Well, I'm still not done. So I get opposite, or negative 7, plus or minus the square root of 49. Oh, I forgot my 6 on there. 49 minus 36, that gives me 13 over 6. Now, 13 is a prime number. It cannot be reduced at all any more than that. Therefore, here are my 2 solutions. And if anybody's at home right now saying, what do you mean 2 solutions? I only see one. I want to point them out with what plus and minus means. I have x equals opposite, or negative 7, plus the square root of 13 divided by 6. And I also have x equals negative 7 minus the square root of 13 divided by 6. So there are 2 solutions. And if you ask me, Mr. Kruger, can I just write it like this with the plus or minus in it? Heck yeah, you can, okay? So I'm going to zip through one more example with you. I think, if I can get that side. Okay, one more example, and then I'm going to have you try the last 2, okay? So I look, 5, yeah, I can tell it's not going to factor. So I know A is negative 5, B is negative 10, and C is 3. So x equals, the opposite of negative 10 is 10, plus or minus the square root of negative 10 squared minus 4 times A is negative 5 times C is 3, all over 2 times A, okay? Now I'm coming along. We don't want decimals for these guys. We want simplified roots, okay? So I get 10 plus or minus the square root of, well, negative 10 squared is 100. This first number right here is always positive because it's squared, okay? Negative 4 times negative 5 times 3. 20 times 3, that would be plus 60 all over negative 10. So I really have 10 plus or minus the square root of 100 plus 60 is 160 over negative 10. Can I simplify the square root of 160? Let me answer the question for you. Yes, you can, because 16 times 10 equals 160, right? So I'm going to look at that as the square root of 16 times the square root of 10. Square root of 16 is 4. Square root of 10, it's nothing. It's just the square root of 10. So this gives me 10 plus or minus 4 square roots of 10 over negative 10. Now, here's what I call happy bunny ears. Happy bunny ears are, if I'm going to reduce this, I have to be able to reduce that by the exact same thing. Can I take the same exact number out of all 3 of those? If I can't reduce it, but in this case I can. All 3 of those numbers are divisible by 2, so I'm going to reduce each one by 2. I get 5 plus or minus 2 square root 10 divided by 5. Boom, shakalaka, there's my answer, okay? So what I want you to do is I want you to try these next 2 quick, and then we're going to be done for the day, but I'm going to pop the answers up here in just 1 second. Okay, when I look, I didn't see I did that. When I look at number 14 there, okay, now I got it back into respects there. A is 4, B is 12, C is 9. And the only reason I'm doing this is because we're in the quadratic formula section here. I plug them in, and lots of times I get answers like this. Well, if the square root goes away, I want you to know, I need to know precisely what the answers are. And I also want you to know, if the square root goes away, even to a number, it would have factored if it's a real number, okay? What are you talking about? Well, this is going to be x equals negative 12 plus 0 is 0 divided by 8. The same way negative 12 minus 0 divided by 8 is this same exact number. So actually, I need to reduce this by a factor of 4, top and bottom. So what is that? I get negative 3 over 2. That's what x is. Notice, I get negative 3 over 2 twice. My discriminant is 0. That means one real solution, but it also means the vertex is on the x-axis, which means it's a double root. Okay? Now, Number 15, sorry if I'm talking fast. I need more coffee, but that's okay. I'm cruising along and I'm plugging in. I'm like, whoa, what happened there? Remember, we reduce radicals. The square root of negative 16 is the square root of negative 1 times the square root of 16. That is an I times that is a 4. That means it's 4i. Don't leave it there because I got to try Happy Bunny earring. Okay, can I divide all 3 of those by the same exact number? Answer is I can divide them each by 2. That's going to give me negative 2 plus or minus 2i. The bottom 2 goes to 1. Because it's 1, I do not need it there. But I should say x equals that, okay? Now, you should be able to track all the work. I showed every dirty, rotten last step through this whole thing on every example I did. So, your rest of your day here is you should go to your try it on your own 3.5, do numbers 1 through 4, 6 and 7, and we will finish the rest tomorrow after I finish this note packet. Have a good rest of your day.